All right, so this video is to teach you how to draw out the unit circle on your own. So I'm starting off with these notes. You guys have already written them down. It's hard to tell, but these are in 3 different colors. Degree is in blue, radians is in green, and ordered pairs is in red. Okay, so if you're watching the video, take a minute, pause, and write that down. We're going to start off with the degrees. It's the easiest one to do. Okay? Hopefully by the time we're done learning this, you'll feel confident that you can draw one out on your own. So the pattern for degrees is 30, 15, 15, 30. The reason those numbers are there is because it's the difference in amount between each of the little lines. Okay? So let's start off by drawing out our degrees. I'm going to do this in blue just like the notes are to match. Okay? This is just a blank unit circle you can find on Google that I whited out the spots. So, remember we said last class that this line here on the right is my starting point. So this is going to be 0 degrees. Okay? And then the pattern, we're going to add 30. 0 plus 30 is 30. Then we're going to add 15. What's 30 plus 15? 45. 45 plus 15 is 60. And 60 plus 30 is 90. Okay? So that gets us our first quadrant. Okay? Now every time I talk about quadrants, it's splitting up the unit circle into 4. So this over here, always starting the same way that the numbers go. This is quadrant 1. Over here, continuing on, is quadrant 2. I'm sorry? This could be in any color. This is going to be quadrant 3, and completing the circle, this is quadrant 4. Okay? All right, so now that 30, 15, 15, 30 continues throughout the entire unit circle. So now again, you're going to add 30 to 90, and you get 120. Now you add 15 to get 135. You add 15 to get 150. And then you add 30 to get 180. Any questions? All right. Again, so the pattern was 30, 15, 15, 30 because I add 30 to get from 0 to 30. And then add 15, add 15, add 30. Do it again. Add 30, add 15, add 15, add 30. And the pattern is going to continue around. So I'm going to take a moment and fill out the rest of the degrees. And then, of course, when we come back to the origin where we started, when we start there, it's called 0, but when we come back, it's called 360 degrees. Okay? And with that, you have completed your degree. Any questions on degrees? Good? All right. So coming back to our notes, radians, I split up the notes by denominator and then by numerator. So I'm going to explain denominator first and then numerators. Okay? These rules are going to be within the quadrant. Okay? So let's start. The 4 most important points on a unit circle is the bottom, top, left, and right. Okay? I am going to also switch over to the green. Okay? So it should make sense that our starting point is 0. What did we say 1 full time around a circle is? 360, but in radians would be 2 pi. So what do you think half of a circle would be? 1 pi, exactly. Cool? Because when we start off the unit circle and we haven't moved at 0, when we go the full time around, it's 2 pi. Okay? So now, on the notes that we had written, we said that our denominators, starting from the x-axis to the y-axis, are 6, 4, 3, 2. Okay? So if we ignore the circle and just look at the lines, this horizontal line acts like our x-axis, and this vertical one acts as our y-axis. Okay? So from x-axis going towards y, upward, and then towards y, downward, we'll have the denominators of 6, 4, 3, 2. So I'm going to draw a fraction with a denominator of 6, then a fraction denominator of 4, fraction denominator of 3, and then a fraction with a denominator of 2. Same thing on the left side. From the x-axis up, we're going fraction denominator 6, fraction denominator 4, then fraction denominator 3, and you can see we get back to the denominator 2. You're going to do the same thing on the bottom, again, working from the x-axis towards the y-axis. So fraction denominator 6, denominator 4, denominator 3, denominator 2, and again from x-axis we have 6, 4, 3, and then 2. Any questions with the denominators? All right. All right, moving on to the numerators. So each quadrant has its own little set of rules for the numerator, but they are all very similar, so it shouldn't be too hard to memorize. Okay? Starting in quadrant 1, well, to begin with, all numerators will have a pi. Okay? Quadrant 1 will have one single pi. Quadrant 2 will have one less than the denominator. So for example, if the denominator was 3, then the numerator would be 2 pi. Okay? Quadrant 3 is the opposite. It will be one more. So if the denominator was 3, the numerator would be 4 pi. And then mathematically, quadrant 4 is 1 less than double. So if my denominator is 3, double that is 6, 1 less would be 5 pi. When I was in high school, the way I memorized it was 5 Slurpees at 7-Eleven because that's the pattern. The numbers are 5, 7, 11. That's just how my brain memorized them. So let's check that out. Again, they're all going to have a pi. Okay? So take a moment and draw a pi on all of them. All right, so quadrant 1 is going to stay with one single pi. We're not going to do anything to quadrant 1 all the way up to the 2 pi. Okay? In quadrant 2, the numerator is 1 less. So denominator is 3, it's going to be 2 pi. Denominator is 4, it's going to be 3 pi. And with denominator is 6, it's going to be 5 pi. Okay? Down to quadrant 3, it's going to be one more. So this will be 7, this one will be 5, this one will be 4, and all the way to the bottom one, this one will be 3 pi over 2. And for the last quadrant, you can say double 3 is 6, 1 less would be 5, double 4 is 8, 1 less would be 7, double 6 is 12, 1 less would be 11, or you can remember 5 Slurpees at 7, 11. All right, so I took a moment and did the parentheses for the ordered pairs in red, just like the notes are. And now we're going to go over to explain those notes. So the first part of our notes says, top, bottom, left, and right. It's like moving one out on a graph. Okay? So if you do take a class like calculus and on after that, the most important parts on the unit circle is the top, bottom, left, and right. That's what gets used mostly, okay? And we'll talk more about that as we keep learning the rest of this chapter. So I want you to pretend like you're on a regular graph. If I were to move 1 to the right on the x and not at all on the y, what would my ordered pair be? 1, 0. And that's exactly what this ordered pair is. Now, how about 1 to the left and nothing up and down on the right? -1, 0. You know, like on a regular graph, if you just move one spot out to the right, move 1 on the x, and I didn't move at all on the y. And now I just did the same thing to the left. Now, how about if I move up on the y and nothing at all on the x? 0, 1. And how about if I move down? 0, -1. Easy? All right, let's go back to these notes. All denominators are 2. So within the quadrants, all ordered pairs are going to be fractions with a denominator of 2. Okay? So take a moment, in all of those parentheses that you drew, draw a fraction bar over 2. In both, in x and y. All right, so we took the time really quick to draw the fractions with denominators of 2. Now, back to these notes, every single numerator is going to have a radical 2. I'm not going to write that yet. I'm going to first show you how to write the numbers, and then we'll do the radicals over them, okay? Now, I've got some silly tricks for you for the numerator. Option number 1, one of the first ways I learned it, is again going from the x-axis to the y-axis, just like we did the denominators for the radians. We're going to drive on the right side of the road, 1, 2, 3, take a U-turn, 1, 2, 3. Okay? And what that looks like, okay? So if I'm doing quadrant 1, I'm going to go from the x-axis towards the y-axis. Out of my ordered pairs, I'm going to drive on the right side of the road and go 1, 2, 3, U-turn, 1, 2, 3. Okay? Now, watch me do just a random one. Like, watch me do quadrant 3. In quadrant 3, I'm going to go from x-axis to y, so I'm going to travel in this direction. I'm going to drive on the right side of the road, and I'm going to say 1, 2, 3, U-turn, 1, 2, 3. It's for all of them. I was just showing you that it works for any of them. Another way you can analyze this is that every time the denominator is the same of the radian, the ordered pair will be the same. So for example, this one says over 6, and now you look over here, and over 6 also has the 3 first and then the 1. Okay? Which means this one that's over 6 will have the 3 first and then the 1. The ones over 4 will both be 2s. And the ones over 3 will be the 1 and then the 3. Okay? So whichever method you choose works. Now, as I go to apply my radicals, the reason why you don't see it on literally every single number, when you look at it on Google, is because what is the square root of 1? Just 1. So even though I'm going to go ahead and place square roots on all these numerators, when I go to place it on 1, square root of 1 is 1, which is why you don't see it appear there, okay? So go ahead and put it on every single numerator. Okay? And we have one last thing to talk about, our signs, whether the number in the fraction comes out positive or negative. Now, the beauty of this is that it works just like the zeros and the ones worked out like a normal graph, so do the signs. So if I move to the right on a graph, on the x, and move up on the y, what are my signs? I have positive and positive. So in quadrant 1, I'm not going to touch anything. Everything is going to stay positive. What about if I move to the left and then up on the y? Negative, negative x, positive y. So in front of all of your x's, take a moment and put a negative. How about if I move left on the x and down on the y? They are both negative. So negative x, I move left, and down negative y. So every single number needs a negative here. Okay? And lastly, quadrant 4, I move right on the x and down on the y. Positive, negative. So the only ones that get my negatives here are the y's. Yeah. So there you go. That is your entire unit.